of our mapper, it doesn't matter. When he see one IP, he just imports it here. I see this once, I put that as a 1. I saw this once, I put this, oh, okay. I put here is 1. Anyway, I put it as a 1. So this is the output for the mapper. And they do the shuffle and the sort, and the input for the reduce job will be like this. We don't need to care about how the shuffle and the sort, how can they do that? It is handled by the Hadoop itself. This is the magic part. So you just need to make sure that you know what is the output for the mapper and what is the input for the reduce. What is the reduce is doing? Do nothing. It enters the values and just add the count. Count the initial value is 0. So what is the get? Get from the values. What is the value? Value is 1. So 1, 1, 1, 1, 1. So it will be how many ones? 5. Then 10 to 5. Then he puts the counts, the word count here. So the output will be key value pairs. The key will be the key for input for this reducer. It will be the IP address. So after this map reduce run, you will know for this log, for this you can get each IP address they find, how many times has been visited. That's the result. Let's go there and take a look what exactly the web log files looks like. This is the original input file. This is IP address. So if we read one line at a time and split by the space, the first segment is the array 0, will be our IP address, right? Do we need to care about the rest of that? Yes, we do, but not for this map reduce. For this mappers, if we just do the count, I just count that and mark as 1. Output for, okay, I get IP address, I input as 1. I get a 1 IP address and put as 1. Then when get to the reduce side, we do the aggregation. Then we count for each unique key how many times you get. Then we get how many times we have already visited this map reduce for this IP address. That is how the map reduce is working. Any questions for that? I'm very sorry, I only can spend very limited time. That if everybody interested into that we can talk more later. But but not now. Okay. Don't think I have a time for demo for this. Let me talk more. Maybe something high-level languages. It's easier to understand. The PIC is also a high-level data flow language. This is developed by the Yahoo. So PIC is nothing new because it's just the interpreter, its execution engine based on the MapReduce. What is the interpreter mean? He just translates the scripts that you're writing here. This is another PIC language scripts. He translates that to the MapReduce job. The MapReduce job is what I show you, what we wrote before, the map functions, reduce functions, even a lot of the customized parts. So PIC is a lot of the user by the DAs because it is a very easy language. I can show you here. If we want to do this transform and read in the MapReduce, it will be 100 lines of the Java. Pick support many features. When you do the transform, so Pick is the ETL language. You can do the joins and dump the result to somewhere. And then you can use these 10 files, then do another joins. You can use in the Pick, just that you are doing your SSIS, the data flow. It's exactly the same. You can group in the data, you can load in the data and dump it to somewhere and do the lookup with some set of the small data. You can just treat it as an ETL language. And some functionality, maybe it's you see in SSIS, that's provided by Microsoft. Pick itself, it has already built-in functions, train everything. But you also can customize this. It's user-defined functions by yourself. It is written in Java, so you can just say, I want to, let me think about it. I want to output some string in some format. Then you can just create a Java project, register these Java files, and the Pick can just use it as a functions in the Pick script. It is very flexible here. I give it one example for the Pick. This is a sales table. The schema is very simple: name, price, country. If the questions will say write a script to read in sales data from a file and find all sales over 2,000 with the highest order first, this is the things that everybody will think, yeah, this is a SQL thing. For sure, yes, SQL can do that. Pick also can do this. So we're loading the data from sales. The sales is the location about your HDFS files. And you give the name, prices, and the country. You don't need to redefine your schema. You're just processing that and you just give it here. It is pretty good. The all sales is the name you gave. Then it will save this as a bag. We call bag is a data set. They save it in all sales. You have one bag of the data now. What are we going to do? Okay, we filter this bag or sales by price. Price we have already named here. Okay, the price, we call it the price column. And the bigger than 2,000. Big sales bag. You have another new bag of the data. Not finished. Sort the big sales. Oh, we need to do the sorting now. The order the big sales by price. Okay. The third bag. You have 3 different bags of the data. Then you store the third bag into the top cells. The top cells here, you need to give exactly the HDFS parts where you want to put this file to. So you can write in everything like that. This is a kind of a data flow. You have one kind of bag and you have put some logic there, and after that you filter that, and another one you join another. Is that the same of our workflow for the ETL? So we call it the ETL script or language for Pick. Again, the backend is still running on the MapReduce. So that's what I want to talk about Pick and Hive. Hive is the SQL for the Hadoop. It's a SQL. You cannot the pig, you have different the bags of temp data they can hold for you for downstream processing. Hive, just you select and you get any things, you analyze the data sit on top of the Hadoop. And Hive is also nothing. Its Hive is come for, I think, by the Facebook. The Facebook is using Hive heavily. I think the three main components Facebook is using is HBase and Hive. Hive is also, the Hive is the interpreter based on the MapReduce. So it is just interpreter your SQL statement to the MapReduce. So the MapReduce that we saw how to write it in the JavaScript. So Hive just do this translate here, nothing else. Hive is a because everything sitting in HDFS is file-based. How do you think that is a database? And how you say how they know it is a table? How they know? It's based on Hive's metadata. So Hive's metadata, the data is not stored in the HDFS. It didn't need 3 copies and it's too slow. It's batch processing. We need to use this. We cannot use HDFS to store our Hive metadata. What is the better the cases to store this transactional data as a metadata? Oh, for sure, it's relational databases. So Hive have its relational databases backend. Normally, it is the MySQL databases. Let me go to here. Okay. Let me run Hive. So how I go to the Hive is just typing Hive. Okay, I'm in Hive now. So the same thing, show tables. You will see a lot of tables there. Is there any tables? Yeah, I have tables here. Oh, moving range. That is not sitting in my file HDFS. We have, that is what I did before for my testing. So I need to drop that. What I to do? I drop the table moving rating. Done. It's dropped. So you see, all the syntax I'm using is exactly the same, I think, for the relational databases. So what you see, when I go inside the Hive, I can do exactly things like, there's a table as orders, so I just orders and limit 5. It will take the nothing there. Okay, that's fine. Let me import some data and create our Hive tables. Then we have some the cases we can run. Okay. Let me do something here. And take a look. I create an external table. What is external table is I will give the location of my file. So it's a user training movie. That is my scoop is landing my file there. So we create our external table. So for the metadata, it will Hive will only create the metadata of our table itself. It won't. If we insert the data, it will go to the user, or not the user, data warehousing. This is by default. If we create an internal table, all the data Hive will holding is in the data warehousing folder. Here we just create an external table, external data. They can land it. They can connect it to our HDFS HDFS file locations to this table schema. And for the schema of this table is they have the ID as int, name as string, and the year as int. And I want it delimited by the tab. And the location is for this is data will be the movie. So if you have already have the data in this location, you can select after you create this table. You don't need to do any insert. And if we run this, it's done. Interesting. I think, okay, it's pretty quick. That's cool. It's pretty cool. So let me create another table. So I create this one as well. So create table is very quick because there's nothing to do, just to have the metadata inserted to the MySQL databases. Oh, it's done again. Okay, cool. Okay, so what is the next thing that I want to do is I want to do the select. I want to select the movie ID, rating name, and join the two tables, movie rating table and movie table. And I want to do the where conditions and the user ID is equal to 149. This is a little bit complex, and see how our Hive handle that. Okay. Ooh, it's launching a lot of programming. What is that? Yeah, we saw that before. It is MapReduce. So it will take a while. So for the performance perspective, you are challenged saying that Hive is not good at all. Yes. For a long time back, Hive is not that good. It will launch in the MapReduce. It is all batch processing. Even you are processing one record, it will also take the same amount of time as it before, as you are doing maybe 100. So in this way, I want to introduce you another toy. Let me launch another one. This is called Impala Shell, I think. Yes. That's what you see here is Impala Shell. It is a Cloudera developed. It is pretty good for the performances. Why? Let's take a look. What I did, I put exactly the same SQL, one from the Hive table of Hive, the window. Another is under. Okay, there's a lot of data set anyway. On the Impala, the formatting is a little bit different, but it's just the response time is just like the relational databases, right? Why is it in this way? Is Impala is have each daemon has a it is a memory intense for sure. And everything they have a lot of is put in the memory, and they never go back to the metadata to ask for the metadata of the table when you submit the query. Everything is already cached locally. And in this way, it's saying if you have 100 nodes for a cluster, in each node, you have one copy about everything, the metadata of the table. But for the Hive structures is different. It's running on the Hive server 2. When you submit your query, Hive server 2 needs to talk to the metadata. Okay, or where is the file located? And where is the blocks? Which data node have these blocks? There's a lot of communications. That is launching the MapReduce and trying to find everything. So it is much, much slower compared with Impala. So Impala still not very stable. If we do the join 1 gigabyte, join another gigabyte, it will out of memory or just hang on there. It is not stable, but it's getting better and better. And the performance, I think they have the benchmark is almost the same of the relational databases. It is pretty good now, what I have see here. Yeah, so let me see what else I need to cover here. Yeah, that's almost that is, I think, I finished all the content I want to cover today. Maybe some part I have no time to explain very detailed. You can email Derek about some things maybe you are more interesting, or you have the questions. So let me get some questions, or do anyone have the questions for the Hive, Pig, or MapReduce?
Yes, we do.
Okay.
Yes, we do. But before we take the question, let me finish one thing. I'm showing my desktop. I hope everybody can see my desktop. Okay, here's the thing, as we mentioned before, we every time will have lucky draw. So today we have 33 people attended online. Also, I put 33. I will have $25 gift card giveaway, Amazon gift card way number 5. I just count from the top by the alphabetic. Cindy is the first one. That way, Dennis, Doreen, and Gary. So, Gary, John, please email me and tell me you actually you are the lucky guy today. So we will give you $25 Amazon gift card. Gary, John, okay. All right, let's take some questions. First question from Simon. Map and a reducer are the only parts we need to write. Is this right?
That is the only part you have to write. But it is if you want to handle more comprehensive logic, each component I show, input split, record reader, shuffle and sort, also you can rewrite that. Everything you can customize, even partition. But by default, you only to write, map, and reduce.
Okay, perfect. And the second question coming from Max. He says actually he observed Impala results are not sorted, but on the other hand, your Hive results are sorted. Is that the reason make the performance look so different?
No, it's not sorted. I mentioned before, for the Hive, it's based on the MapReduce. For each reducer, because you have a shuffle and a sort, each reducer is sorted because this is a MapReduce framework. But it is not for performance to sort it. But it's not global sort. Because for here, we only have one, because the data set is very small. It is only have one reducer run. So that's what you see here, the result is sorted. This is not impact the performance. Even I can do the order by, still the Impala is very quick. Here it is the chance that because there's one reducer, this is a. Oh, you give me back my. Okay.
Here you go.
I still want to go back to my MapReduce. Give me 1 second. Where is it? Here. As I mentioned that before, that shuffle and sort if you have one reducer, the data has been sorted because they have a shuffle in the group all the values for the key. But if you have multiple reducers, it is not a global sort. You cannot make sure that the A, B, C, for example. So it is a key value pairs, okay? So we have the, what is name? Andy. We have our Alex. We have Derek, Serena, and Max. Okay, we have all this kind of things. This is a key. How we key knows which reducers to go is by partitioner. Hash partitioner know that Andy is always go to first. If Derek will be second, it will be partitioned this way. No, they don't know. It's by byte. So hash partition didn't know. It's maybe hash partitions on the output. Can be the Derek. You are in partition 1, and with the Max. And the partition 2 can be the Andy, Alex, and Serena. But for Andy, if you have something 1, okay, 2, 3, 4, give it something. If you have the 5, I give it some numbers. It's a key values. So for the Derek and Max, you are in the same partition and output as the one reducer. It will sort by its locally, only Max and Derek. So Max, you have 5, you will be later, it will be sorted, and Derek, you have 3. But for the Andy, you have 1 here. So all the results you are presenting is like this, if you are query by the Hive. So is it sorted or not? No, it's not. Only partially in the reduce you have sorted. Does that make sense? Serena is a 4.
All right,
so
last
if
question.
you query the results, it will be like this. It is a partially sort, but not a global sort. What is the last question?
All right, last question is about can you compare Impala versus Spark?
That's a good question. So we will have the okay, so there's a couple of things here. Let me write down here. Hive map reduce, Hive Spark SQL, Impala. So everybody is dedicated on the CQs for the Hadoop. There's the 4 kinds of the CQs will be here. So it will be Hive MR that you see the lowest the performances. Hive Spark will be coming in 2015. Hope so. This year, but don't know when is that time. All the teams rewrite the engine or the interpreter is trying to using the Impala. So it's not coming yet. So there's no way to compare the performances. Also, we have the Spark SQL. It's a kind of the I'm not very familiar with that, but it's the performance with the Impala and the Spark SQL. I heard it. Impala is still better for that. Because Spark is still not that mature. Even they have a lot of good features, processing everything in memory, but it's still not production ready, I have to say.
All right. I guess that's the question. And all right. Yeah, so if you have some other questions, please email me. And also you can find us from the website. We have not website, it's a LinkedIn group. The LinkedIn group is Chinese, past Chinese, secret past Chinese, someone is asking. So we have, let me switch back. We have actually, a group. If you search by name, it will be secret past Chinese, global Chinese. And also, one more question from earlier on. Someone mentioned the link is broken by just try it. It works. Let me show you how it works. So this is a group. Search by name, you can find us, and here's the link I posted. Usually, don't be tricked by this one. You should copy the whole thing in your IE. Try that out. All right. So this is today's session, and thanks again to Serena share us the knowledge.
Oh, Derek, I want one thing that I want to ask. There is someone is interested in to want to get the Cloudera Dev certifications. Maybe we can get some study groups for that, right? That's what we have already talked.
Right. So that's something we are talking about. A couple of things. We are actually discussing whether we need to maybe open a session for the members or whoever who interested to join. We will have a Cloudera session. Probably starts in the middle of March, maybe by the end of March. Yeah, that's probably a plan we'll still discuss, and maybe the integration service in the middle of the year. Right now, we almost finished the reporting service, quite good, and positive feedback from the students. So keep tuned. Every time we'll post the message on the LinkedIn group, so you should receive the notification. And if you're not yet joined us, please join us. All right, that's it. All right. Thank you, everybody. Have a good night. See you next time, actually.